So back in geometry, you guys should have learned about Pythagorean triples. When you've got a right triangle, there are certain side lengths where if you know two of them, you can find the third one without even having to use the Pythagorean theorem because they're integers and we memorize them. So one of the most famous ones, the one that I always see in math books, is 3, 4, and then what happens to the hypotenuse? Can't hear you. 3, 4, 5. Oh, okay, there we are. There we are. So this is a triple where if you have two legs that are 3 and 4, you don't even have to use the Pythagorean theorem. You will already know that the third one is 5. Just like if you have one leg that is 3 and you have the hypotenuse that is 5, you can just know that the other one is 4. Now, if the hypotenuse is 4, that's not a 3, 4, 5 triangle. Because I think there was one in section 4.3 that was a 3 and a 4, but the hypotenuse was one of them, right? That was the one you were working on? Yep. Okay. Now, because of 3, 4, 5 works, anytime I enlarge that triangle or I shrink it using similar triangles, like if I had 30, 40, guess what the other side would be? Thank you, 50. I know, that's a hard one. So they're proportional. So if you know 3, 4, 5, you know any combination of 3, 4, 5. 6, 8, 10. So this 3, 4, 5 is very handy to memorize. I took an ACT class, not learning ACT, but I took a class that was for teachers of like juniors who might need ACT help. And this guy went through and they took like the last 11 years of ACT tests and they separated all the questions into categories, and he said that knowing your triples will save you so much time on the ACT. He said it seemed like all the geometry questions, if there was a right triangle involved, it had a triple. So talk about time saving on a time test. These are important. So that's not the only triple. There is also 5, 12, does anybody know it? 13, that is one. There is 8. Does anybody know this one?
24, 25.
Oh, that's 7, 24, and 25. You got part of it. 7, 24, 25. Does anybody know the 8 one? Yeah, it's 15 and 17. 8, 15, 17. And then again, any triples, any multiply those all by 10, multiply those all by 2, multiply those all by any number, then we've got similar triangles, and it would always work. So I'm giving you that ahead of time because there are going to be some triples in our assignment. Okay? Now, I just want to make sure my camera is working on. All right, good. It's still working. Last time it wasn't working, so I couldn't get the... Next is, let theta be an angle in standard position and let a point, xy, be any point on the terminal side of theta. So here's a picture. You can see the orange in the picture is part of a circle. You can see my point, xy, is graphed. It is somewhere on that circle. And theta, which is also in orange, is the angle of the rotation. The red line is the terminal side, and along the x-axis is the initial side. If I were graphing that ordered pair, I would start at 0, 0, and I would go to the right, x amount. Then I would go up, y amount. And that's how I get the ordered pair x, y. Right? So how long is this side down here, the horizontal side of the triangle? How long is that? By the way, it says the answer. It is x long. Whatever number x is, that's how long it is. And how high up? It is y. That's the height. So the third thing is, what is the radius of the circle? So the radius of the circle, let me do this in like a highlight. The radius of the circle could be here. The radius of the circle could be here. The radius of the circle is also here. like the radius of the circle happens any place on that circle. So I'm going to get rid of 2 of them and just look at this third one here. We use the distance formula, and we can find the measurement of this radius of the circle. Or, I actually should say or, we can use the Pythagorean theorem to find the length of r. The Pythagorean theorem says to do x squared plus y squared equals r radius squared, or c squared, but it's going to be r in this case. And to solve for r, you just square root both sides. And that is written right here. That is the radius formula. So if you were given an ordered pair, and I have one here that we're going to do that's not on our notes, but I'm going to put it in right now. We're going to be given an ordered pair. The ordered pair is 12/13. Oops. And 5/13. That's my ordered pair. We are going to find all 6 trigonometric ratios of this theta from an ordered pair. So what we do is we say, okay, from this ordered pair, I'm going to form a right triangle. I'm going to use my x amount, which is 12/13. I'm going to use my y amount, which is 5/13. And now I have 2 sides of the triangle. How do I find the third side of that right triangle? Pythagorean theorem. Pythagorean theorem. All right. Wouldn't that be nice if this was a triple? Wouldn't that be nice? Just saying. Let's do Pythagorean theorem. 12/13. Oops, that's a 13. 12/13 squared plus 5/13 squared equals r squared. So 144 over 169 plus 25 over 169 is 169 over 169. I'm going to square root both sides. And what does r equal? 1. So this triangle has a hypotenuse of 1. This is actually a triple. That's why I said that earlier. Can you figure out which triple it is?
5, 12, 13.
It is the 5, 12, 13, but it is not just 5, 12, 13. It's taking that 5, 12, 13 and multiplying everything by 1/13. So it is that 5, 12, 13. They just multiplied everything by 1/13. So again, using triples, if you didn't know the triple, you just have more work to do. The problem is, I know that in the past, questions like these have been on quizzes in the non-calculator section. And then, if you know 13 squared, great. What happens if you don't know, like, 24 squared? You got to multiply it by hand, and that's a pain. Okay, so I'm telling you these now. These aren't on your quiz that's next class, but they could be on the quiz coming up a few classes from now. Okay. All right, so once you have all 3 sides, then you can go ahead and find sine, cosine, tangent, and their reciprocals. We don't need to go through all of the work for that, but there's a question like that in the assignment. What I do want to draw your attention to is this chart right here no longer says SOHCAHTOA. Look at, do you see there's no SOH? You see that? So SOHCAHTOA is geometry, algebra 2. We are not in very high level math yet. Now we're in higher level math. I am getting rid of, starting in section 4.2, I'm getting rid of saying things like opposite over hypotenuse. Because we're going to put all of this stuff on an XY axis. We're going to put it all on a Cartesian plane. So when we start talking about it on a plane, we're going to use x, y, and r. You see where those are in the picture? The x, y, and r, that's what we're going to use now. We're not going to use opposite, hypotenuse, and adjacent. All right, so these would be something you need to know. The sine of theta is always y over r. Now, if you look at the picture, and I do the sine by going opposite, that is where the y is, and the radius is where the hypotenuse is. So it is the exact same thing, but we're going to be saying it differently. So the sine is y over r, and I am going to be super annoying and make a nasal sound. So I remember that sine is y, okay? Because we got to remember. So sine is y. Got it? Sine is y over r. And then cosine is x over r. But I just have to know one of them so I can figure out the rest of them. Sine is y over r. Cosine is x over r. And then tangent is y over x. Now for cosecant, secant, and cotangent, I don't have those memorized. I just flip the first three. So if I know that sine is y over r, then cosecant's going to be r over y. If I know that sine is y over r, then I know cosine has to be x over r. It's the other side. And then tangent is the two sides on top of each other. And tangent goes in the order that I write it in. Sine, then cosine. Y, then x. See? Y, then x. All right. Now, in the next example, if we have something called a unit circle, which we will have a lot of soon, if we have something called a unit circle, in the unit circle, the radius is 1. That's all a unit circle is a circle that has a radius of 1. So this example that I took from the book that we just went through is on the unit circle because our radius was 1. Okay? If the radius is 1, we can adjust the above ratios. So instead of sine being y over r, what's r now? So since r is 1, sine is now what? What's y over 1 though? Y. So sine is y, only in the unit circle. But we are going to do a lot of the unit circle coming up soon. Sine is y. So that means cosine is x. And tangent did not have an r, so tangent is still y over x. Now, for cosecant, secant, and cotangent, all I do is reciprocate the first three. So if sine is y, what's cosecant? 1 over y. Secant, 1 over x. Tangent, or cotangent, x over y. So I know the first three, and I just flip the second three. I mean, I probably have them memorized by teaching it for years and years and years, but literally every time I do an assignment, I still think about sine and then flip it. That's what I do every single time. I do want to show you something, though. Because of this here, look at this first example we did. What is the sine of theta? Take a moment, take an extra half a second. What is the sine of theta in this example that we did with the 3 sides that I took out of the book? 5/13. What did you do, Tempest? So you did y over r, and you simplified it, okay? But if I already know the radius is 1, the y value is sine. So this is sine, the ordered pair. And cosine is x. That's cosine right there. I mean, you can do 12/13 over 1, but that's just one extra step. We'll do more of that. Okay, the next thing is something called a reference angle. And these should be super easy points that you can get when I'm asking you what that reference angle is, but they are really important and we will have to use them a bunch. But just to start, finding a reference angle. So a reference angle is always positive. It is also always acute. So what that means is the number has to be between 0 and 90. It cannot be negative. It has to be between 0 and 90. It has to be less than 90. Or if it's in radians, then it would be between 0 and, what's 90?
1.57.
As a pi. Pi over 2. Okay. So if you're asked to find the reference angle, what you will do, and I've got 4 examples over here in this corner, over here in this corner right here, is you're going to look at the actual angle. So here, it's not really colored. Let me see. The actual angle, I'll do blue. The actual angle starts at our standard position, and then it's rotating, and here's its terminal side. This is in quadrant 2. The reference angle is the angle that connects the terminal side to the x-axis. The reference angle connects the terminal side to the x-axis. It's right here, theta. That's our reference angle. In the first quadrant, I probably should have started with the first quadrant. Here's the terminal side. The reference angle connects the terminal side to the x-axis. In the third quadrant, here's our angle. The reference angle connects the terminal side up to the x-axis. So we're going to the x-axis every single time. And then in the fourth quadrant, the terminal side to the x-axis, that's the reference angle. So here's like 4 examples on how you could find the reference angle depending which quadrant it's in. All right. So we're going to evaluate 6 trigonometric functions at each real number. There's an explanation why it's called T. I don't really want to get that involved with it, so we're just going to say that T is the angle. Okay? So I'm going to start with my circle and my initial side. And we're going to rotate just pi over 6. Okay. It doesn't look like a T. I feel like I need to zoom in more. Okay. Now, the first thing you want to do is you want to figure out the reference angle. Okay? So pi over 6 is a radian, and until we know exactly what pi over 6 is every single time, we might need to think about it as degrees for a moment. So remember that day where I told you how to kind of take that top half, divide it into how many equal places for pi over 6? 6 equal places. And each of those would be pi over 6. And we're just doing the first one. What degrees would that be? It would be the same thing as 180 divided by 6. And I think I heard a man say 30. Was I right? There was a boy that said that over there. Okay, so we're thinking this is a 30-degree angle. Now, again, until you have it memorized, which you will get it memorized soon. Don't worry, we'll get it memorized soon. What you have to do is you have to know that we have a 30-degree angle in that spot where I wrote a T. I actually kind of want to get rid of that T now. I think I'm going to just put a 30 in there maybe. I don't know, I feel like I can't write it because it's too small. Ooh, I can change how thick I write. There we go. There we go. So that's my 30 degree, that's my pi over 6. Now I'm going to go over that and I'm just going to use a highlighter. And I'm going to think about going to the ordered pair that is right here, I'm going to think about getting to that ordered pair. I would start at 0, 0. I would go right. That color doesn't show up. Let me do a different color. Do red. I would go right, and then I'd go straight up, and that's going to make the two sides of my right triangle, and the third side will be the radius. Okay? Now I'm just going to draw that triangle separate so we can just look at the triangle itself. Okay. Now if you drew your original picture big enough, you probably don't need to redraw the triangle, but I didn't draw it big enough. So we have to find all 6 trigonometric ratios for this picture. So while you're drawing your triangle, I'm going to start writing sine pi over 6, cosine pi over 6, tangent pi over 6, cosecant pi over 6, secant pi over 6, and cotangent pi over 6. In order to write those, we either have them memorized or we draw the triangle every single time and we find them every single time. Your choice. What kind of triangle is this? 30, 60, 90. Okay. So then if it's a 30, 60, 90, and I was going over this on the board when you guys were working on your review and somebody asked me a question, if it's a 30, 60, 90, we have formulas. What's across from the 30 degrees? What's across from the 30? 1. Or you can just put A. It's up to you. What is the hypotenuse? 2. And then the third side? Square root 3. So now we're going to find the sine of that angle. So the sine is 1 over 2, 1/2. Okay. Now I'm going to tell you right now, every single time that you have a 30, 60, 90 degrees, and you are asked to find the sine of 30 degrees, it will always be 1/2. It will never not be 1/2. It will always be 1/2. So if I say, Dylan, what is the sine of 30 degrees? Dylan's going to say 1/2. Good job, Dylan. Sebastian, what is the sine of 30 degrees? Very good. William, what is the sine of 30 degrees? Good job, William. Mia, what is the sine of 30 degrees? 1/2. Sarah, what's the sine of 30 degrees? Good job. Now, who's not paying attention? Who should I call? Ilya, what's the sine of 30 degrees? Good job. Stephanie, what's the sine of 30 degrees? 1/2. All right, now I'm going to change it up. I'm going to make it harder, and I'm going to call on Kevin. What is the sine of pi over 6? What'd you say, hon? You don't know? It's written right there. It's right here. No, what is the sine of pi over 6? Okay, let me go back. I'm going to go back. Tempest, what is the sine of 30 degrees? Tempest.
1/2.
Good. Now, what do we know about 30 degrees and pi over 6? They're the same. So now, Kevin, the answer is 1/2. Good. Nico, what is the sine of pi over 6? Good. It does not matter if I ask you today or tomorrow or a week from now, your answer should be 1/2 every single time. Hopefully, some of you memorize that. Okay, let's keep going. The cosine at pi over 6, that is the exact same answer as the cosine of 30 degrees. Square root 3 over 2. And I'm just getting that straight out of the picture. Actually, I'm lying. I have it memorized. However, you're probably using the picture and doing adjacent over hypotenuse. Or doing, in here, you're doing x over r. Tangent is going to be y over x. So 1 over square root 3. However, that has to be rationalized. And I do it really fast only because I have it memorized that the tangent of 30, which is pi over 6, is the one with all the 3's. That's how I have it memorized. The tangent of 30 degrees is the one with all the 3's. See, I'm going to give you hints because you have to have these memorized. All right, the cosecant and then the secant and the cotangent, I'm going to flip each one of these. So when I flip 1/2, I get 2. When I flip the second one, I have to rationalize it, but I know the answer because I have it memorized. So this is the answer for secant. And then for tangent or cotangent, I'm actually going to flip it before it was rationalized to make it a little bit easier on myself, and it's just square root 3. So if you're asked to find anything for pi over 6 or 30 degrees, these are always the answers. Always. So we memorize them. The next one is 5 pi over 4. So we're going to start by thinking about where that could be. And we're counting by pi over 4s. So that means I take my pi, which is 180 degrees, and I divide it into 4 equal places. And then I count 5 of them. So here's my initial side. Here's my terminal side. We're going to find a point on that terminal side. That's like part of the circle that I didn't draw. Whoa, that was really ugly. Let's see if I can do it better. A little bit better. Okay, and we're going to get there by doing from 0, 0, x, y. And now we have a triangle. The ordered pair is xy. The radius is r. Now, until you have these answers memorized, I'm going to walk you through it until you have them memorized. What is this angle right here, which, by the way, is going to be called our reference angle? What is the angle inside of that triangle that goes to the x-axis? A little bit louder.
45.
45? So yes, but tell me in radians for a second. It is 45 degrees, but since we're 5 pi over 4, and I was counting 5 pi over 4s, what's this one right here? Just pi over 4. So our reference angle is a pi over 4 angle, which somebody already yelled out, that's 45 degrees. So that's exactly where my brain goes. I say, well, the reference angle is pi over 4, and pi over 4 is 45. And then I do everything knowing that it's 45 degrees. So my triangle, which I'm just going to recopy so I can write on it again, my triangle is 45, 45, 90. Well, I need the formulas for 45, 45, 90. William, do you know those formulas? For the 45, 45, 90, do you know the side lengths?
Yeah, A,
Now, if you use any number for A, this will work. So I could use 1 if I want. If I use 1, I'm going to rewrite it with 1s instead. If I use 1, here I'll put it in a different color. It'll be 1, 1, square root 2. And it's easier to do it with those rather than have the variables in there. You can totally have the variables if you want. Now, that isn't 100% matching the picture. This triangle isn't 100% matching the picture. It's close, but it isn't 100%. Does anybody know how it's not matching the picture? Chris, are you talking? Was that Chris or was that Kevin? Oh, you changed your mind? Okay. Okay, let's do this together. We take our pencil or our stylus and we go to 0, 0, and we go to graph this. Where do we go first? to the left. And then we go down. How is that different than the triangle I just drew over here? Cameron?
Right.
I went right. It's not? What happens when you go to the left to the x value? Oh, it's negative. Did I draw a negative one up there? So this is how putting it on the xy axis changes between just having a triangle and finding sine, cosine, tangent. Now we can have negative numbers. All right, that's what's different. So as you are doing this, you need to be aware of which quadrant it's in. And if I go left, it's going to be a negative. Oops, that's not what I meant to do. If I go left, it's going to be a negative 1. If I go down, it's going to be a negative 1. Will the radius of the circle be a negative number? Radius is never negative, it's a length. Negative in our triangle just tells us direction, but it does affect the answer of what sine of 5 pi over 4 is. Okay, so now, sine 5 pi over 4, we do y over r. I'm just going to write this down because we have to memorize these, y over r. So you could be on the graph if you wrote it down here. I mean, I can write it down here, -1, -1, square root 2. So I'm going to do my y value. Oh, I could make my ordered pair too. -1, -1. I'm going to do my y value, which is -1, over my radius, which is square root 2. That does have to be rationalized, and you get negative square root 2 over 2. Cosine, we do our x over r. So we do -1 for x, square root of 2 is r. Rationalize it, you get negative square root 2 over 2. Why are those the same answer? Because our sides are the same length, exactly. These will always be the answer for sine and cosine at a 45 degrees, always. So if you know these, you've got to memorize they're the same answer. You only have to memorize one thing and know that they're the same. And then tangent for a 45-degree angle is always the same answer as well. We do y over x, which is -1 over -1, which is 1. So those are always the same when you do sine, cosine, and tangent of 45 degrees. The only thing that could be different would be negatives or positive, depending on which quadrant it's in. And then to do the other three, I just flip them. So if I flip, if I rationalize something, I flip it before I rationalized it. So I'll flip that one, which is just negative square root 2. And if I have the cosecant, my secant is the same. And then my tangent, if I flip the number 1, it is still 1. Oop, that's not tangent. My bad. Cotangent.
Why is there a -1?
Why is there a negative what?
-1.
Oh, -1 where? Because there's quite a few negative ones. Can you be more specific which one you're looking at?
Where did you get it from?
Oh, well, do you know why there's ones up here? Do you know why there's ones?
But I don't know why you turned it negative.
Because of the quadrant that I graphed it in. So since I'm going to the left and down, that's going to be -1, -1. Because we have to include location and the length of 1. Okay? All right. Now, when you flip it over, or you're not flipping it over, you don't have paper, sorry. When you look at the next page, we're doing the exact same thing, but these are just a teeny bit different. So if I'm looking at 0, so I've got a circle, and I have my initial side, and then I rotate nothing. That means my initial side and my rotated side, my terminal side, are the exact location, same location. I can't make a triangle. But all of the rules still apply. So the sine of 0 is still y over r. The cosine of 0 is still x over r. The tangent of 0 is still y over x. I just can't make a triangle, but I can find these pieces of information. So if I am starting at 0, 0, and I'm going over, how far did I go over? Let me write this ordered pair. How far did I go over? Somebody said something. If I started 0, 0, Luke, help me out. How far did I travel to get there? A little bit louder. Right, so what's the radius?
R.
Okay.
1 arrow. 1.
Are there numbers anywhere? Are there numbers anywhere?
No.
Then you can't give me an answer that's a number. And Luke, you are correct, but I'm looking for a different answer. Somebody else go off of what Luke was saying. He told me what the radius is because the radius and what I'm asking for are the same. But I want to know if I were going and writing this ordered pair, what would be the first thing I write? Louder? Oh, was that you? Yes. Yes, William. X. That's how long it is. It's X long. And then how high up do I go for my Y? This one actually has a number. 0. I'm not going up at all. Okay? So that ordered pair is go over X, up 0. And yes, the radius and the X do equal each other in this case. The radius and the X are the same. So now we can fill this out. Y is 0. The radius is X. And what's 0 divided by X? It is 0. We need to know that if we have a number, 0 over a number, it always equals 0. Okay, cosine is X over R. So my X value is X. And my radius is also X. So my cosine at 0 is 1. And if you type in your calculator, cosine 0, enter, it will tell you 1. Tangent is y over x. So y is the ordered pair 0, and x from the ordered pair is x. So it'd be 0. Okay, and then we flip them. So cosecant, secant, oh my gosh, I want to make that into a theta so bad. Cotangent. So when I flip each of these, what happens if I flip 0 over a number? What happens if I have a number over 0? Yep. And if you type in, well, you can't really type in cosecant, but if you try to type in the cosecant of 0 using that 1 over sign 0, it will tell you error. So undefined. Secant at 0. We're going to flip 1. Still 1. And cotangent, undefined. All right, next one. This time, we're looking at pi. So that one would be, start here, and we end over here. You will not have a triangle for this either. Any of them that land on the axes, you will not have a triangle. If you land on the axes, you have to use the ordered pair. You have to. So let's find this ordered pair, x, y. So if we start at 0, how do I get to x? How long is it? It's x long, but I'm going this direction, so I'm going to write negative x, yeah. And the y value? 0. And our radius? So is radius ever negative? No. Radius is always positive because I could put the same amount right here and it would still be x long. Okay? So now we just do our 6 trigonometric functions. The thing that takes me the longest is writing this. Maybe if I have time, I'll make a worksheet where it's already written for you. But at the same time, I want you guys to write it because you have to know them. It's like I'm torn what I want to do. So sine is y over r. So we look at our picture. Our y value is 0. Our r value is x, and we get 0. Cosine is x over r. When we look at our x place in the ordered pair, it's negative x. Our r value is x, so we get negative 1. Tangent is y over x, so we do our y value over our x value, and it simplifies to 0. And then just flipping them, undefined, this one's undefined, and then this one's still negative 1. All right, one more of that kind. Evaluate this, and I drew those in there for you this time. That was nice. At negative pi over 3. So I gave you a negative example. I'm going to go over here. And so what's the difference? When it's negative, pi over 3, what's the difference? We're just going the other way around. So we're looking at the bottom half being divided into 3 equal places. Okay? And I'm only going to one of them. Oh my gosh, I can't draw a straight line over there. I got to redo it, sorry. There we go. So if this is pi over 3, negative pi over 3, what is the reference angle? What is the reference angle? So you're still going to say radians, okay? You are correct, it is 60 degrees, and I totally think about this being 60 degrees. I'm totally going to think about it being 60. But if I were to ask you the question, what's the reference angle? Somebody is speaking. Pi over 3 would be the right answer. Why didn't he say negative pi over 3? Anybody remember? We didn't do any examples yet, so does anybody remember? So the reference angle is never negative. It's just like how much is that theta inside of that triangle? That's a pi over 3, which is 60 degrees. But we're going to say pi over 3 would be the reference angle. Okay, because it's 60 degrees, this is a 30, 60, 90 triangle. So we can go and put our information in. Since this one is 60 degrees right here, that means the one down here is 30. And now I'm going to put in my side length for x that says that's going to be 1. What's going to be my y value? Never mind. What's going to be my hypotenuse? Okay, 2. So what's going to be my y value? So everybody says radical 3. That's right, except we are now in the 4th quadrant. So to get there, I'm going to have to go 1, but then I'm going to have to go down radical 3. So I'm going to use the negative. The length isn't negative. I'm talking direction, which is important for our answer. So we've just done these a bunch of times in a row. I, of course, put it way over there, so now I can't have them both in the same picture at the same time. So sine is y over r. Cosine is x over r. Tangent is y over x. So my y value was negative square root 3. My r value was 2. That's reduced all the way. Cosine, 1 over 2. tangent is negative radical 3 over 1. I don't have to write the over 1. Just negative radical 3. Then for cosecant, we're going to flip each of these and rationalize, which I'm doing super fast because I already have it memorized. And you get it memorized, you can do it super fast too. But these values will keep coming up over and over and over and over again because they are special and they are the ones that happen over and over and over again. They're the ones you have to know. All right, and then the last stuff, well, there's two last things. So we don't really need to do all of this, but if you're doing 13 pi over 6, if I went pi over 6's, if I divided the top half into pi over 6's, 6 would fit. So I kept going all the way around, I would get 12 pi over 6 if I made one full circle. So this one's just a little bit further. So when I talk about the reference angle for this, I'm talking about pi over 6. So now I'm using a triangle that has pi over 6 right here. And what is pi over 6 as degrees? 30 degrees. Excellent. Jeffrey, what is the sine of 30 degrees?
Half,
Yes. Did you have it memorized?
I guess.
You guess? Or did you look?
I will.
Okay. Okay, you guys fill this out. This might be the vet. Answer it. Fill that out. Hello? Please don't call anymore. It was not the vet. Never mind, I'll continue. Okay, so what I was hoping somebody would memorize the 1/2 since I asked about half of you that question. I'll keep asking you as we go. Cosine of 30 degrees, or cosine of pi over 6 is radical 3 over 2. I have it memorized. Or you can plug the stuff into your triangle. This takes way longer. And figure it out. Tangent is the one with all the 3's. Radical 3 over 3 is the tangent of 30. Tangent of 30 is the one with the radical 3 over 3. It's the one with all the 30's. Okay. And then for this one over here, same thing. You're going to count by pi over 2's in a negative direction. So we'll go negative 1, 2, 3, 4, 5, 6, 7. So it ends right on the axis. And if it's right on the axis, you have to use the ordered pair. So what ordered pair would be right here? What would be the x value for going straight up? 0.
Y.
Yep, 0y. And then what would be our radius?
Y.
Y is correct. So sine would be y over r, which is y over y, which is 1. Cosine is going to be x over r, which is 0 over y, which is 0. And then tangent would be y over x, which is 1 over 0, which is what? Undefined. All right, this is the last thing now. Just using your calculator, you literally just have to type stuff in. But the biggest thing about this is, I might answer it again. Type this in your calculator. Let's see that we all get the same answer. I'll do it too. Hello. Yes. Okay, so to type in tangent pi And that is going to be, sorry, 0.6421. And then for cosine 45, you can change it back into degree mode to do cosine 45. So and then the last one is secant 1.8. So you have to type in 1 over cosine 1.8.